Let us quickly solve this problem. A boy drags a bag of rice along a smooth horizontal floor with a force of 2 Newton applied at an angle 60 to the floor. The work done after a distance of 3 meters is what? So the first thing is that you bring out your parameters. So a boy drags a bag of rice along a smooth horizontal floor with a force of 2 Newton. It means that our force is equal to 2 Newtons, right? Apply at an angle 60 to the floor. It means that our angle theta is equal to 60 degree. Now, the work done after a distance of 3 meters is what? So the question is asking us, the work done is what? What is the work done? So the question is asking us, after a distance of 3 meters, means our distance is 3 meters. So now we have all our parameters. But for you to understand this question very well, I have to draw the bag of rice. I have to draw the diagram. So now let's say this is our diagram here, everyone. Now this is our bag of rice. This is our rice. Now the boy is dragging the rice. Okay, so let's say this is horizontal and this is vertical like this. Now the boy is dragging the rice at an angle of 60 to the horizontal like this. This is it. So the boy is dragging the rice at an angle 60 degree to the horizontal like this. So the force that the boy is applying, F is equals to 2 Newton. Can you see? The force is 2 Newton. Now, look, you see the force that this boy is applying. Ordinarily, the boy is supposed to be dragging the rice horizontally like this. That would make sense. So, but the boy is now dragging the rice at an angle of 60 degrees to the horizontal. Now, the thing is this. You see this 2 Newton. It is not everything that will move the rice horizontally. And the force that makes sense to us, that the boy that is moving the rice horizontally, is this horizontal component. This 2 Newton is not the 2 Newton that will move the rice in horizontal direction. Part of it will move the rice in vertical direction like this, which is F in the force in the vertical direction, and part of it will move this in the horizontal direction like this, which is F force in the horizontal direction. And now we have to look for the force, part of the force that the boy applied at an angle, part of it. We have to look for the part of it that is moving the rice horizontally, because this force that the boy applied at an angle has the tendency to move the rice upward, vertically upward, and it has the tendency to move the rice horizontally like this. So we have to look for the one that makes sense to us, and the one that makes sense to us that is going to move this rice, because the boy is not trying to move the rice vertically upward, he's trying to move the rice like this. So the force that is moving the rice horizontally is this, and this is F in the horizontal direction, Fx. So now we have, and that's what we normally say, we want to resolve a force into vertical component and horizontal component. And after, sometimes you will make use of vertical and horizontal components. Sometimes you make use of any one that you like. But in this sense, we are going to resolve this force into vertical and horizontal component. But the one that makes sense to us here, that is moving the rice, is the horizontal component. So that is what we want to get. That's why we cannot just say force times distance here, because this 2 Newton is not everything that is moving the rice horizontally. Part of it is moving it vertically because it is applied at an angle. So now this is it. Look at it. We can complete this diagram like this. That is this Fy. We can put it here. But since the Fy, we are not using it. So let me just bring the diagram like this so that you are going to understand. Now, this is F force in the horizontal direction, and this is our angle theta. This angle theta, and this is the force that the boy applied, F. You can see. Now we are looking for this force in the horizontal direction. Now you can see that this one is the force in vertical direction, but this I can still bring it here. Now let us look for this force in the horizontal direction. This is angle 90, right? This is adjacent. This is a right angle triangle. So if you can remember your like this. So this is the force that we need is adjacent. We are given the hypotenuse. Now we have the angles. That's adjacent and hypotenuse. So this is adjacent and hypotenuse. That's going to be cos. So we can say cos theta is equal to adjacent, which is force in the horizontal direction, over hypotenuse, which is our F. So if we cross multiply, that means force in the horizontal direction is going to be equal to what? It's going to be F cos what? Cos theta. F cos theta. So, meaning that we cannot say our work done now equals to force in the horizontal direction. You can see I did not write ordinary F. So, force in the horizontal direction times what? Times distance. Now, our work done is equals to F cos theta times distance. Now, what is our F here? 2 times what is our angle? That's 60. That's cos 60 times what's our distance? That's 3, right? So equals to 2 times cos 60 is what? Is 1/2. That's 0.5 times 3. So 2 cancel 2, and our work done is going to be equal to 3 what? 3 joules, because work done is measured in joules. So that's how we have 3 joules. So whenever you want to find, sometimes they can say a boy is dragging a box, it may not be a bag of rice. Most times, the formula that we normally use is, you don't even need, you see, I said the other time that I don't need to draw the diagram, but I just drew the diagram to show you this is the formula that we normally use when something is being dragged at an angle to the horizontal. So we use work done equals to F cos theta times distance. I could have just used this formula because it's JAMB question. I already know the formula to use, but I just needed to show you why we use this force in the horizontal, because the force they gave us has the tendency to move this thing upward and horizontally, and the one that makes sense, that is effective, is this horizontal. So I have to resolve it. That's why we say let's resolve this force into horizontal and vertical component. But after that, we pick the horizontal component because that's what is useful to this question we are trying to solve. Thank you.